What's up? I'm Vin, and today I want to go through the August 2022 Algebra 1 Regents. I'll leave a link to this test in the description below so you could follow along, and let's get started. So first up here, we want to find f of 8, and we have this function here. Now, you can use a calculator for this, but we could just go ahead and plug in 8. So we're going to have 3 times 8 plus 4 divided by 2. And when we work this out, we're going to have, this is going to make 24. So 24 plus 4 is going to give us 28 divided by 2, and 28 divided by 2 is 14. So this is going to be choice 3. Now, if you're nervous and you don't trust your mental math, you could always go to the y equals here. You press alpha y equals enter, and that's going to pull up a blank fraction. You press 3x plus 4 divided by 2. And if we press second graph here, notice we could just scroll down. And if you don't like fractions, you could always press mode, switch from the answers here from auto to decimal. And when we go to the table and we scroll down to x equals 8, you'll notice the corresponding y value is 14. So definitely choice 3. So for question 2, we want the common ratio of this sequence here. And what we could do to find the common ratio is the common ratio r is the quotient of any two consecutive terms. So let's say I would just take the first two, x and 2x squared. If I do 2x squared divided by x, this is just going to be equal to 2x. So right away I know my answer is 2x, but just know I could divide any two consecutive terms. So if I divided 16x to the 5th by the one right before it, if I do 16x to the 5th over 8x to the 4th, well, 16 divided by 8 is going to give us 2. And when I divide exponents that have the same base, like this is going to be a to the b minus c. So I'd have x to the 5 minus 4 is x to the first, and I still get the same answer. For question 3, you should know this formula for the Regents. A squared minus b squared is a difference of two squares, and it factors very nicely to a plus b times a minus b. So when I do these questions, what I'm thinking of in my head is I'm thinking of the square root of each term. So for the interest of this Regents, we could just say the square root of 36x squared is 6x, and then the square root of 9 is equal to 3. So then that tells me when I want to use this formula here, I'm taking the square root of each term, and then I'm writing those square roots. We have 6x plus 3, and then we have 6x minus 3 like this. Okay, so that's just a way to actually use this formula, is you take the square root of each term, and you write the square root of the first thing plus or minus the square root of the second thing. And this is going to correspond to choice 3. Now, one thing to make note of here, just know in general, the square root of x squared is equal to plus or minus x. And later on, you don't see this as much in Algebra 1, but you could also call this the absolute value of x. But once again, for questions like this, when we're doing this math in our head, we could just go ahead and take the square root of 36x squared to be 6x to get us choice 3. Now for question 4, we have a relation r, and we want to know which value of x would make this relation a function. So right away, what I need to note here is that if we have a function, the x values do not repeat. Okay, so this is a massive idea. They do not repeat. So when I think my way through this, and I look at the x values that are already here, what I tell myself is that x is not the x values that are already there. And we already have negative 4 as one x value. We have 3, and we have negative 1 showing up. So that means negative 4 is out, x equals 3 is out, and x equals negative 1 is out. So by process of elimination, our answer choice has to be 4. Question 5, we have this point, and it's lying on the line whose equation is given by this, and we want to know the value of k. So for this, just know that k corresponds to x, and y is equal to negative 5. So just plug in. We're going to have 3 times x equals capital K, plus y is minus 5. So I can just write 3k minus 5 equals 7. And then now we could just solve this. We do plus 5 to both sides to cancel out this. And now we have 3k equals 12. And to get k by itself, the opposite of times 3 is to divide by 3. And that's going to give us capital K is equal to 4. So definitely choice 4. Question 6, we're using the distributive property. But one thing we have to be careful with is that we're multiplying by 1/3 and x. So when we actually distribute here, I'll just write the result over here. We're doing 1/3 times 6. And then we're doing x times x squared. Okay, then next we have 1/3 times negative 3. So I'll just write minus, we have 1/3 times 3. And then we have x times x. And then last we have a positive times a positive. So we're going to have plus 1/3 times 9. And then times x. Now just know, because of commutativity of multiplication, I can move around the order in which I multiply, but the reason why I multiplied in this specific order is that the terms that can combine are the numbers and then the x times the other x terms. So if I do 1/3 times 6, in my head what I do, you could use a calculator for this, depending on how strong your mental math is. And if you do 1/3 times 6, you could always do 6 divided by 3 is 2, and then 1 times 2 is 2 like this. Or what you could do is you could do, if you're doing this out in your head or actually showing the work, 1/3 times 6, call it 6 over 1, and then 1 times 6 is 6, over 3 times 1 is 3, and 6 divided by 3 is 2. But either way, this is going to simplify to 2. We have x to the first times x squared. If we're a little rusty with our exponent properties, when we have the product of two exponents with the same base, all we have to do is add those exponents together. So x to the first times x to the second is going to be equal to x to the 1 plus 2, or x to the third power. And now we have minus 3 over 3 cancels nice. Or you could just do 1/3 times 3 is 1. And then we have x to the first times x to the first is x to the 1 plus 1, or x to the second power. And now here we have plus 1/3 times 9 is 3, and we have an x that's just going to tag along. So now we just have to scan the answer choices here. These are automatically gone because they're x to the second, and then this one looks like it's the answer choice, choice 3. Question 7, we have a bunch of graphs that represent 4 polynomial functions, and we want to know which of these functions have zeros of 2 and -3. Now, what you need to know for this question is multiple representations. The zeros of a graph are the points where the graph intersects, or I'll just say crosses, the x-axis. Okay, so that's another word for the zeros, or the x-intercepts. So when I look here, notice if I just count, I got 1, 2, 3. So I have an x value of 3 and an x value of -2. So that doesn't match what we need to happen here. We need zeros at x equals 2 and x equals -3, but that doesn't happen here. Now when we look at this one, notice we have a root at x equals 2. If we count 2 boxes over, and then if we go backwards 1, 2, 3, we have a root at -3. So right away this one's looking good. But now before we go on, we should look at why the other answer choices are wrong. So here we have a root at -2 and we have a root at -3. So while -3 is one of the roots, -2 is not. So we could cross this one out. And then this one here has roots at x equals 2 and x equals 3. So while x equals 2 is a root, x equals 3 is not. So definitely choice 3 here. So question 8 is all vocabulary. So you either know this vocab or you don't. So for this one here, what you could do is write this in standard form with the highest power of d first. So we have this plus this plus this. And the constant term is always the number at the end that doesn't have a variable attached. So our constant term here is 6. So choice 1. So question 9, just know you have to have this formula down. A equals P times 1 plus or minus r to the t power, where r represents the interest rate. And one thing to point out here is this, the interest rate as a decimal. Okay, so it has to be in decimal form. So let me just make that a little bit neater. So decimal form. Okay, so here we have Emily was given $600 for her graduation. She invested it in an account that earns 2.4% interest. So right away, I know this is going to be the plus case because it's earning money. This is not a situation where the money is depreciating in value. If she does not make any deposits or withdrawals, which expression can be used to determine the amount of money in the account after 4 years? So this is t equals 4. Now to find out the r value, r is equal to, just know, 2.4%. As a decimal, we would do 2.4 divided by 100. And if you do that in the calculator, 2.4 divided by 100, as a decimal is going to be 0.024. So right away I could see this one's a trap, 1 and 2, because this would be 24%. 24% would be 24 out of 100, and that would be 0.24 like this. So those two are automatically out. And now which one are we going with? We're going to be going with choice 3, because you see this is 1 plus the interest rate, because this account is earning money. Okay, if the account was losing 2.4%, then we would do the minus here. But since this is earning 2.4%, we're going with choice 3, not choice 4. Question 10, we have these 3 data representations. We want to know which ones have a median of 2. Now for representation 1 here, what you could do to speed things up is you could just count how many pieces of data are there. So at 0, we have 2 pieces of data, then we have 4, and then we have another 2, we have another 3, we have another 2 entries here, and then we have 1 and 1. So in total, if you're adding this up in your head, this is going to be 6, and then we have plus 2 is 8, then we have 11 when we add this, then we have 13, 14, 15. So this is equal to 15 pieces of data. Now, how does that actually help us speed things up? Well, what I imagine is that we have 7 items, and then we have the median here, and then we have another 7 items to make 15 total items. So what that tells me is that I'm counting for the 8th item. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the median is going to be at 2 here. So Roman numeral 1 is definitely part of the solution, which eliminates choice 3. Now, this will take quite a while. Now, there's a second way to find the median in Roman numeral 1, but this would take quite a while. So we could list all the data here and then just cross off each end like this. Cross one off the left and one off the right. And we repeat this until we get to the middle value here. And if we do it this way, we should also, if we do this correctly, we should also get a median of 2. So that's a second way of getting this. So it depends which one makes you happier. Now, for Roman numeral 2, you have to know how to read a box and whisker plot. And just know that this value here represents Q1. This value here in the middle of this bar here represents the median. So right away, I could see we have a median at 2 here. And then over here, this is Q3. And then this is like the last value here. So this is like our min, and this is our max. So this is just for reading box and whisker plots. So here we have a median of 2, which means Roman numeral 2 is part of the mix. So that eliminates choice 2. And now the last thing to verify here is, does the last data representation also have a median of 2? But this I would do the same way that I did Roman numeral 1. That notice we have a frequency of 1, and then we have a frequency of 3. We have a frequency of 5. Then we have a frequency of 3 again. And we have a frequency of 4. And then 3. And then for the last one, we have a frequency of 2. So I would see how many items do we have in total. And this is going to give us 4 plus 5 is 9. 9 plus 3 is 12. Plus 4 is 16. And then if we add 5, we have 21 pieces of data here. So the thought process is I would have my first 10 items. Then I would have my median here. So my middle item. And then I would have my remaining 10 items like this. So what I would do is count for the 11th item. Okay, because if we have 21 items in total, the 11th item is in the middle of the 21 items. So now if we look, so far we have 1, and then we have another 3. 1 plus 3 is 4. And then we have another 5. 1 plus 5 is 9. And that tells us that the 11th item is going to be here in this mix. Okay, I could also do this by brute force. I mean, I could just list 0 once, and then I could list 1 4 times like this. But we'll just trust the process here that if I think about it carefully, that my 21st item is in this category here, which we do not have a median of 2 in the third case here. So this is looking like choice 1. Question 11, if you want to do this without a calculator, just know that when you have a coefficient in front of x squared, as the absolute value of the coefficient increases, the graph becomes more narrow. Okay, so the graph becomes, and let's spell this correctly, becomes more narrow. Okay, so keeping that in mind, what I look for right away is I see that this one would be the most narrow. Now, some people might look at that and say, wait a minute, -5 is the smallest number out of 0.5 and 3x squared, but the absolute value of -5 is equal to 5, and that's bigger than the other two coefficients. So this is the most narrow. Okay, and we want to organize this from the most narrow to the widest. So f of x should be first, which eliminates this choice and this choice. Now, the next most narrow graph would be h of x, because 3 is a bigger number than 5. Okay, so the absolute value of this coefficient of x squared is equal to 3, and the absolute value of 0.5 is equal to 0.5. So this one would be second, h of x, which eliminates this. So g of x with the smallest absolute value coefficient would be the widest graph. So choice 4 is looking like the answer. But let's be real. On test day, you might be really anxious. You might be checking things like 1 plus 1 is still equal to 2. So if you really want to be safe here, just type them in the order you think that they're most narrow. And if I write -5x squared first, and then next we said 3x squared, and then last we said 0.5x squared. And we graph all three of these. I'm going to press zoom 6 just to make sure everything's in standard form here. And notice here that the blue one is definitely more narrow than the red one, and the red one is more narrow than the black one here. So this is the correct order. So question 12, we have a survey that was conducted to see if students prefer cheeseburgers, pizzas, or hot dogs for lunch. Here's the results of the survey. What percent of the students prefer pizza? So the concept for percent is you're looking for part over whole. So the part that we're looking for is what part of the students in this survey prefer pizza. So what we would have to capture here is how many people like pizza. Well, there's females and males that like pizza. And so far we have 44 plus 30 students that prefer pizza for lunch. But now we have to consider what is the total amount of students in the school taking this survey. So now I'm going to divide by all of the students that took the survey. So there were 32 females that like cheeseburgers, 36 males that like cheeseburgers. The amount of people that liked pizza are part of the total population, so we'll add them as well. And then the people that like hot dogs, we have 24 females plus 34 males like hot dogs. The rest is calculator work. So if you really want to be neat typing in your fractions, you could press alpha, y equals, and enter, and this pulls up a blank fraction. And now we can just type everything in. We have 44 plus 30 on top, and then we have this sum on bottom. So after we type everything in here, we can just press enter. And as a percent, 0.37 is 37%. If you really want to just turn it into a percent, just multiply your decimal by 100. And that's going to write your decimal as a percent. So 37% of the students prefer pizza. So we're going with choice 2. Question 13, we want to know which situation could be modeled by a linear function. And just know linear functions have a constant rate of change. And the rate of change is always the coefficient of x, the slope. So this is our rate of change. And the b term, the y-intercept, represents the initial amount. So now we can just scan the answer choices here to see which one matches up with this type of equation. So if we have the value of a car depreciates by 7% annually, well, let's say the car was like, I don't know, $10,000. This was a long time ago. Then the value of the car would be 1 minus 0.07 to the t power, but this is an exponential function. So since this is an exponential function, which I'll abbreviate, this does not fit the description. So here we have a gym that charges a $50 initial fee, then $30 per month. So this is definitely looking like a linear function here. And if we had to model this with an actual function, we could say that this is equal to the initial fee is the plus 50 at the end, and then we have 30 times x, where we're paying this much per month. So this would capture how much we would pay for X months of service at this gym. But now, just to make sure the other answers are no good, we'll go through them. The number of bacteria in a lab doubles weekly. This would be an equation that has something times, let's say, 2 to the x, because multiplying by 2 repeatedly doubles your function, but this is an exponential function, so this would get rid of choice 3. Now for the last one, this one we could also cross out because this is just like choice 1, except this time the amount of money is increasing by a certain percent, so this is also exponential. So definitely choice 2. So question 14, which function has the smallest y-intercept value? So there's a few ways we could find the y-intercept, but one way is to set x equal to 0. Now the second way to find the y-intercept is when you have a graph, the y-intercept is where the graph crosses the y-axis. So this is the y-intercept. So now for the first one here, set x equal to 0, and when x is equal to 0, the y value is positive 1. So our y-intercept is b equals 1. And now when we go to choice 2, to find this y-intercept, we would let x equal 0. And when we plug in 0 for x, we're going to have the square root of 0 minus 3. And when we do 0 minus 3, this is negative 3. So our y-intercept is negative 3, which is less than positive 1. So this eliminates choice 1 because we want the smallest y-intercept. Now for choice 3, the y-intercept occurs when the graph crosses the y-axis, and this happens at b equals minus 2. But minus 2 is not less than minus 3, so we could eliminate choice 3. And now for the last one here, when we plug in 0, we're going to have 0 squared plus 2 times 0 minus 1. And this is going to work out to minus 1. So our y-intercept is negative 1, which is not less than negative 3. So we cross off choice 4. Choice 2 is definitely our answer. Question 15, when solving this quadratic equation by completing the square, which equation is the step in the process? Now, when you are completing the square, one of the big techniques that you need to know is you're going to take half of the b term and you're going to square it. So that's the first thing I do kind of in my head is I take the b term, negative 10 in this case. I'm taking half of it and then squaring it. Now, half of negative 10 is negative 5. And when we square that, that's going to give us positive 25. So now if we write this quadratic equation over here, we have x squared minus 10x minus 13, and let's just make that neater, equals 0. The first thing I like to do is isolate the x squared and the x term. So we'll start by adding 13 to both sides. And now we've got x squared minus 10x. I'm going to leave a space, and on the right side we have 13. So completing the square, what that actually means is that you're adding a number to the quadratic to turn it into a perfect square trinomial. Now the common perfect square trinomials, we have x squared minus 2x plus 1. That's equal to x minus 1 squared. And I'm using minus here because our question is in terms of a minus x term here in the middle. And next I would have something like x squared minus 4x plus 4. This is x minus 2 squared. And then I could do x squared minus 6x plus 9. This would be x minus 3 squared. And then for the next one here, let's say I fast forward to 10x. If I have x squared minus 10x plus 25, that's equal to x minus 5 squared. Now, the reason why I'm looking at these is because, once again, the idea is you want to add a number to both sides to turn this into a perfect square trinomial, but this is the technique you have to be able to do on the side or in your head. You take half of the b term and square it, and that's the number that you add to both sides. So I'm doing plus 25 on both sides, and now the left side, x squared minus 10x plus 25 factors nicely to x minus 5 times x minus 5. So just know in general this, if I had to do this the long way, is going to be x minus 5 times x minus 5, because negative 5 plus negative 5 is negative 10, and the product of negative 5 and negative 5 is positive 25. But this I could just simplify like this. So now I have, and I'll just write this in a different color here, we have x minus 5 squared on the left is equal to 13 plus 25 is 38. So now when we scan the answer choices here, this is going to match up with choice 1. Question 16, when written in standard form, the leading coefficient is. So this is all vocabulary, and you have to know two things. What is standard form? That's when you write your polynomial in descending powers of x, the greatest power of x first. So 2x to the third would go first, then we would have 3x squared, then we would have 7x, then we would have minus 6. And the leading coefficient is the number in front of the leading term. So here, the leading coefficient is the coefficient of x to the third, which is going to be 2, and that matches up with choice 2. So question 17, we want to know which equations have the same solution. So what we could do here is we could just solve all three equations. So if we start with this one here, 10 times x minus 5 equals negative 15. There's a few ways we could do this, but one way we could do this a little bit differently. We could divide by 10 first, and that's going to get the 10 over 10 to cancel, and then we'll have x minus 5 equals, and if you punch in negative 15 over 10, this simplifies to either negative 3 over 2, or you could simplify this to negative 1.5. So when you add 5 to both sides like this, you're going to get x equals negative 1.5 plus 5 is going to give you 3.5. So now let's just make that a little bit neater. So this is going to be 3.5. So now we could solve the second equation here. And the second one I'll solve in this little space over here. We have 4 plus 2 times x minus 2 is equal to 9. Now this one, let's say we start by distributing. So we'll have 4 plus 2x minus 4 is equal to 9. Notice 4 minus 4 cancel out. And now we have 2x equals 9. Dividing both sides by 2 gives us x equals 4.5. So right away we can see these two are not equal. So 1 and 2 we could eliminate like this. 1, 2, and 3 could also be eliminated. So now the $1,000,000 question is 1 equal to 3, or is 2 and 3 going to be equal to each other in terms of having the same solution? So now let's go ahead and solve that last one here. And to solve this one, the 1/3 x equals 3 over 2, what we could do is multiply both sides by 3 over 1. Because when we multiply by the reciprocal of the coefficient, it cancels out to give you just 1 times x equals, and we'll have 9 over 2, which simplifies to 4.5. So this tells us here that 4.5 shows up for the third equation and for the second equation. So these two are going to be equal to each other. Now, question 18 is a bit of a strange question, but what we have is a function c of d, and we want to know another representation for this function. So the actual property that you would use to do this purely algebraically would be this exponent rule. When you have a power raised to another power like this, that's equal to a to the b times c. So for this question here, c of d, what we could do is we could express this as 120 times, and I'm going to use this rule but backwards. So instead of 2 to the 3 times d, we could call this 2 to the third raised to the d power, because if we had to, we could do 3 times d is equal to 3d. But now if we simplify this, this is 120 times 2 to the third power is 8. So we have 120 times 8 to the d, and that's going to give us this answer choice here. Now let's say you forgot the algebra here and you were nervous. What you could do is you could type in the question. So we had 120 times, and I'm just going to go ahead and write this. We have 2 to the, instead of 3d, we're just going to put a 3x instead. So we have this, and then we could type in all the answer choices. So now that everything's typed in, what we could do is we have the question in blue, and then we have choice 1, 2, 3, and 4. And this worked out to choice 4, which is going to be the green one here. And if we press second graph here, and notice we have the question starts at 120, then 960, 76, 80. And the only one that matches this is the fifth column here. We have 120, 960, 76, 80. So this one here is kind of just a calculator trick if you're really stuck. But hey, it's a test and multiple choice. They don't check your work. They just check to see if you got it right. So this is a nice little trick for questions like these. So for these kind of questions, what you should do is you should start out with what they give you. So we have 10x squared minus 12x minus 16x equals 6. And notice that there are two steps here. George writes this, and then he writes this immediately after. So looking at what George does, I notice there's a minus 14x in parentheses, but notice there's only a single x term, and here we have two x terms. So first, George is going to combine like terms, and negative 12x minus 16x makes negative 28x, and this is equal to 6. But notice there is no combine like terms thing going on here. But then next, what George does next is he actually factors out a 2 here. So if you take out a 2, you're going to get 2 times, and you would have, if you divide each term by 2, you'll have 5x squared minus 14x, and this is going to be equal to, on the right side we have 2 times 3. So what George actually did here is actually the distributive property. So this one definitely shows up. Now most people think of the distributive property as just going from this form here to this form that I'm writing after the equal sign. But believe it or not, when you're doing something like, let's say 2x plus 3x, what you're actually doing is the distributive property but backwards. You're taking out the common x, and then you're doing 2 plus 3, and this is equal to 5x. The thing is, you do so many of these that you don't even realize what your brain is doing, but it's actually doing the distributive property, which is kind of backwards here. So that shows up first. And then the next thing George does is notice that there's no more factor of 2. So he essentially just divides both sides by the same term here, and that leaves you with 5x squared minus 14x equals 3. So he divided both sides by the same thing, so we could call that the division property of equality. So he uses D and then B, so this matches with choice 4. So question 20, we're looking at a recursive sequence. And anytime I hear this phrase here, I just know the next term, so the next term is built by the previous. Okay, so this is just a big idea for recursive sequences, but the next term is built by the previous term. So when we use that idea for this, we're starting with a1 equals negative 2. So we have a1 equals negative 2. So when we want to find a sub 2, using this formula, I'm going to plug in n equals 2, and that's going to give us a sub 2 equals, and then we're going to have 3 times a sub, and we have n minus 1. So n is equal to 2, so we have 2 minus 1, and then plus 1. And now this is going to give us 3 times a sub 1 plus 1. And this is where the first few times I'll show this is I'm going to write it out very thoroughly here, but just know the big idea is the next term is built by the one before. So notice we have 3 times a sub 1, but we just were told that a sub 1 was equal to negative 2. So we're going to have 3 times negative 2 plus 1, and that's going to give you negative 6 plus 1, which is negative 5. So that's a sub 2. But then when we get to the next term here, a sub 3, you'll start to notice the trend is that it's going to be 3 times, and this would be n equals 3. But if we plug in n equals 3, and we have 3 minus 1, that's going to give us a subscript of 2. So we'll have 3 a sub 2 plus 1, and this is going to be 3 times negative 5 plus 1, and negative 15 plus 1 is going to give us negative 14. So this is the value for a sub 3. But now we got to just do this one more time. So next up here, to find a sub 4, that's when n equals 4. We have a sub 4 equals 3 times, and if we were to plug in 4 here, we'd have 4 minus 1 is 3. So we have 3 times a sub 3 and then plus 1. But we just found a sub 3 to be negative 14. And now we're just adding 1 like this. So if you do 3 times negative 14, that's going to give you negative 42 plus 1. and this works out to negative 41. So that's the value of a sub 4, which matches up with choice 1. Now, question 21, we have a lot going on here. We have a swimmer set a world record for a 1500 meter freestyle, finishing the race in this much time. And if 1 meter is approximately 3.281 feet, we want to know which set of calculations could be used to convert her speed to miles per hour. Okay, so what we're starting out with is we have 1500 meters in 15.42 minutes. So notice all of these are starting the same. So far all the answers are in the mix, but what we need to happen is we need units to cancel out so that at the end, after we do all of our multiplying, that we wind up with miles per hour. And just know the only way units actually cancel is when you have matching things on top and bottom. For example, I'm 6 feet tall. If I wanted to convert my height to inches, I would multiply by 12 inches over 1 foot because there are 12 inches in 1 foot. But then notice feet is on top and bottom, so the feet cancel out. And when I do 6 times 12 and get 72, the only unit left on top is inches. So that's how we convert in a simple case. So if I look at choice 1 here, I look for anything that cancels out. And notice minutes cancel out right away. And then the next thing that cancel out is actually nothing else cancels out. And no, I know this is not the answer choice right away, because if I do meters times miles, at the end, we're going to have square meters miles. And that's just not making sense at all. So this one is out. Now, if we look at the next answer choice here, we have 1500 meters over this. And now what we need to wind up with at the end is miles per hour. So something like this, feet over feet cancels. And then the next thing I could look for to cancel is meters. Notice meters cancels like this. And then minutes cancel, minutes over minutes cancel. So right now, all we're left with is miles per hour. So this choice is looking really good. Okay, there are 60 minutes in 1 hour, 3.281 feet per 1 meter, which was given to us. And in 1 mile, there's 5,280 feet. Now, the reason why these choices are no good is that once we cancel this out, meters cancel out. Notice that what we're left with, after feet cancel out, we're left with miles per minute. And we want miles per hour. So this one's gone. And now when we look at the last answer choice here, we have meters over feet. So this one here, minutes cancel. But then our units at the end would be meters, miles over hour, feet, which is not miles per hour. So this one's out. Definitely choice 2. Question 22, we have the diagram of a graph of h of t, which models the height of a rocket after it was shot in the air. So the domain, in general, domain means possible x values. But in this case, since we're dealing with a function of t, we could also say possible t values, because once again, this is a function of time. So when we look here, the possible t values, we're going from 0 to 4. And this makes sense because the rocket is launched, and then when it comes back to the ground, that's when the situation is over here. So the domain would go from 0 to 4 seconds. So that eliminates choices 3 and 4, which are massive distractions. This would actually be contenders for the range, which are the possible y values, because notice the rocket reaches a maximum height of 64 feet, since h of t is telling you the height in feet. So that would actually be referring to, once again, to the range. But now here, the $1 million question is it choice 1 or 2? And in this case, we're going to go with choice 2 because the brackets mean that 0 and 4 are included in the domain. And that makes sense in the context of the question because we do care about the very start of the question when the rocket is immediately launched and the moment that it hits the ground at t equals 4 seconds. So that's why we're going with choice 2 and not choice 1. Question 23, we have this set of data here for time spent on electronic devices and math test scores, and we want to know the correlation coefficient to the nearest hundredth for this set of data. So this is all calculator work, but the first thing we should do before we calculate the correlation coefficient is we go to the catalog, and you could scroll down to the letter D, or if you want a shortcut, press alpha, and then the x to the negative 1 is where the letter D is located, and you press this, and then you scroll down, but that means you could skip A, B, and C, and you're going to scroll down to diagnostic on and press enter. Just make sure that this is on because this could mess you up with some of the data entry questions. And now let's type in the data. So we're going to press statistics here and we're going to edit and we're going to go to this table here and I'm just going to clear this out here. So I'm going to clear and press enter and notice my table is empty and now I need to enter in list 1 and list 2. So now that we entered the data from the question, what we're going to press next is stat, and then we're going to calculate a linear regression here because the actual question said the data collected modeled a linear regression. So we're going to select option 4. And now we're just going to press enter until we get to calculate, and we're going to press enter again. And now this gives us all that we need. The R value here, our correlation coefficient to the nearest hundredth, we have negative 0.977. So to the nearest hundredth, this is higher than 5, so we're going to round this to 98. So we have negative 0.98. So this is going to match up with choice 1. Now, one thing we should know here is that correlation does not imply causation, but the data does suggest that if you spend too much time on an electronic device, hopefully not in class, your math test scores will drop. You can see here the students that spend 7 hours on their electronic devices here are not having the greatest test scores, whereas the kids who spend the least time are getting higher math scores. They're just saying there's a correlation. Correlation does not imply causation. So this question here, we have the equation v equals this, and we're solving it for b. So let's just go ahead and write this out. We have v equals 1/2 a, and then we have b plus c times h like this. So what we could do is we can multiply both sides by 2 first. And what that accomplishes is it's going to get rid of this fraction 1/2. So now we've got 2v equals, and we've got a times b plus c times h. And now what I could do is I'm going to write this h next to the a. I'm going to rearrange this as 2v equals a times h times b plus c. And this I could do because multiplication is commutative. I have this times this times this, so I could choose to multiply a and h first. But now, since our goal is to solve for b, what I'm going to do is I'm going to divide both sides by ah. And now what that accomplishes, this cancels out on the right, and now this is going to bring us over here. We have 2v divided by ah equals b plus c. And since b is what we want, we could just go ahead and subtract both sides by c. And now the c's cancel, and we have 2v over ah minus c is equal to b. And this is going to match up here. Let's go scanning the answer choices for this. This is going to match up with choice 4. Now, before we close this out here, let's say you had done the question like this, where you distributed the 1/2 ah, and you got these two fractions over 2. You combine the fractions, cross multiply, and you ultimately get to this step here, b equals something like this. Now, some people might say, wait, how is this matching up with the same thing here? But notice if you do it this way, that ah's cancel out like this, and you would still get that b is equal to, and you have 2v over ah minus c like this after ah over ah cancels. So there is more than one way to get to this answer here, but me personally, if I could avoid doing the distributive property by dividing both sides, without distributing, I always find that to be the cleaner solution. So that would be the preferred way to do this, but there is more than one way to get to choice 4.